drop a like. Go now and drop a like onto the live video wherever it is going on. Yes, can you guys do it for me? Everyone, can you guys just do it for me? Just go a like. Go and press the like button there. It won't take it won't take more than 30 seconds or so. Yes. And that would be a lot of encouragement for us to continue doing whatever we are doing. Okay? Well, guys. So let's get started with today's session. Yes? Now, let's have a look at the questions that we have already dealt with. We have understood that. Now I want answers. What do we need to do good learning in this session? Yes? We need interaction. That is the only thing that we need. So let's get started. What is only arrangement? Anyone, everyone in the chat box. Nasreen, I can see. What is only arrangement? It is R factorial. Very good, Revati. Yes. What is selection and selection and arrangement? Selection and arrangement is NPR. NPR. Revati, selection and arrangement is NPR. Selection and arrangement is NPR. What is selection? Selection is NCR. Selection is NCR. What does NCR mean? Selecting R people out of total of N people is NCR. And then we later moved on to understanding the two strong pillars of permutation and combination, that is AND and OR. And then we moved on ahead on working on identities. What were those identities? I'm giving you a quick brief about yesterday's class. Identity was NC1 is equals to N. The other identity was NCN is equals to 1. The next one was NCR is equals to NCN minus R. Yes, these were the identities. Next thing we went to was calculations. We understood how to make fast calculations. We took up a few examples and solved it. And then we later moved on to a question where we were trying to form a committee of 7 members using 6 men and 5 women. Okay, how do we deal with it? We always, in permutation and combination, what do we do, guys? We start with the condition that is given to us. What was the condition that was given to us in the first question? Any 7 members. Any 7 members, how can we select? We looked into it. Next, exactly 7. At least 3 women, at most 3 men. These are the different conditions that we took up there. And later we moved on to the next set of questions which were forming numbers. Whenever a condition is not given, we can form infinite number of numbers. When a condition is given, we change accordingly, and we start from the condition. We start from wherever the condition is given to us. Yes? Whenever you see a 0, one important thing that we took a note of was whenever we look at a 0, the 0 itself is a condition. And then from there we moved to arranging people. In arranging people, what did we see? First thing that we saw, when the number of people is equals to the number of chairs, when the number of people is equals to the number of chairs, there is only arrangement. That's when we got to know that R people, R chair is R factorial. That means only arrangement. Later we moved on to the next type of question where we solved. What did we solve, everyone? What did we solve? Are you guys making notes of whatever we are doing? It is a good habit to make notes, please, guys. Today it might look easy when you are solving together, but tomorrow it will be all Latin and Greek. If you do not make notes, please make note of whatever we are learning in the on the daily basis. Yes, and brush through it once a week. Yes. Now, next thing that we learned was all boys sitting together. And the next condition we learned was boys and girls in alternate position. Then we went to no boys sitting together, which was a typical case. In no boys sitting together, if you guys remember, what did we do? We placed the girls first, created spaces, and then dealt with the question. Now I would go a step ahead. Pay attention, because this is going to be very tricky, Pay attention. Here, the condition will say something like this, okay? There are 3 boys and 3 girls, okay? There are 3 boys and 3 girls, and exactly 2 girls always sit together. Always sit together, okay? Now, what will happen in such a case? Look, pay attention. Now, there are 3 boys and 3 girls. 3 boys, how many? 3 boys and 3 girls. Now, always, what is the condition? Always 2 girls are sitting together. Always 2 girls are sitting together. Now, if I do not understand, what am I supposed to do? I'm supposed to write a case. Now, 2 girls are sitting together. Girl, girl, boy, girl, next boy, Next, where can I place the boy? I can either place him here or either place him here. But if you observe what is happening, these two girls are moving as a single unit and this girl is also moving. But where are they appearing? Where are they appearing? Now, if I start placing my boys, boy, boy, boy. Yes, the girls can appear either on the left of the boy or right of the boy. Either they can appear on the left of this boy or the right of this boy. Or the left of this boy or right of this boy. Yes, do you agree? Do you agree? Now, start thinking. Start thinking. The girl can be girl 1, girl 2 or girl 3. Girls can be girl 1, girl 2 or girl 3. Now, always two girls are sitting. What are the different conditions that can appear? Girl 1 and girl 2 can sit together, or girl 1 and girl 3 can sit together, or girl 2 and girl 3 can sit together. Only 3 ways. Now, let's deal with only one among them. Only one among them. Now, these two girls can occupy what all positions? First position, second position, third position or fourth position. It is similar to what? Similar to what? I am treating this as one unit, and this one unit can be placed where the number of people, number of chairs are greater than number of people. So it can occupy first, second, third or fourth. In how many different ways can they sit? 4 ways. 4 ways. Now, as soon as I make them sit in 4 ways, there will be another girl G3 who will be left empty. Yes. Now, let's say the girl 1 and girl 2 occupied this position, whichever position you are comfortable with, girl 1 and girl 2. Do not try to solve this question, just listen to it. This one question, if you solve it properly while listening to it, the next question I'll give it to you and you can try it out, okay? Just pay attention. Girl 1 and girl 2, let's say they occupied this position, They can take how many positions? 4 positions, I have written it there. Now, there will be another girl, girl 3. This girl can occupy what all positions? This one, or this one. How many different ways can she sit? She can sit in 3 different ways. She can sit in 3 different ways. Now, the girl 1 and girl 2, they can rearrange among themselves. 2 people, 2 chairs. In how many different ways they can arrange? They can rearrange in 2 factorial ways. Next, these 3 boys, they can be boy 1, boy 2 and boy 3. So they can also rearrange among themselves. In how many different ways can 3 people sit? They can sit in 3 factorial ways. But is this the end of the answer is my question? Is this the end of the answer is my question? No. Why? Start thinking. What have we done here? We have dealt with a one case where girl 1 and girl 2 are sitting together. But girl 1 and girl 3 can sit. Girl 3 and girl 2 can sit. So what is that I need to do here? I need to multiply it with a 3. So what will this give me? 4 3s is 12. Again, I have a 3 into 2, it is 6. Yes, 2 factorial is 2 itself. 3 into 2 is a 6 and 3 factorial is 6. 36 into 12. 12 3s is 36. 12 6 is 72. That gives me 432 ways. Everyone understood this? Previously, they were a little bit easy. Why? Because the condition was easy. But here, the condition is what? 2 girls are always sitting together. Are you satisfied? With this? Look, I'm repeating this once again. Everyone pay attention. What do we do? What should be our approach when such type of a question appears where it says exactly 2 girls are always sitting together? We have to make them sit together. So 3 girls will be there. It can be G1, G2, G1, G3 or G2, G3. Yes, these are the 3 possible combinations among those 3 girls. Yes, now, so 3 ways they can sit. 3 I've written here. Next thing, I'll start placing my boys initially and create spaces in between them. Now, this set G1, G2 can occupy first position, second, third or fourth. So, in how many different ways can they sit? 4 different ways. Now, every time I use one set, another girl will be left out. Here also one girl will be left out. Who will be that? G2. Yes, here also one girl will be left out. Who will be that? G1. Now, that girl can occupy one among these 3 positions, the 3 that I've written here. Now, these girls can rearrange among themselves. That is, this can come here and this can go there. That is 2 factorial. The 2 factorial I've written here. Now, these boys can rearrange among themselves. 3 factorial. How many ways can 3 people rearrange among themselves? 3 factorial. That also I've written here. Now, finally, I've written another 3. Why? Because there are 3 combinations that are possible. So, I've multiplied it with a 3. That gives me 432 ways. 432 ways. Everybody, were you able to understand? Everyone in the section, everyone in the YouTube as well as Zoom, are you guys able to understand? If such type of a question appears, will you give a same approach and will be able to solve it in the examination? Yes or no? Yes or no? Yes or no? Be quick to reply here. Now, yes, let's move ahead. Now, I'll make it a little bit more complicated for you, okay? I like it making your life a bit more complicated. I like it. Let's say, this time the question will be something like this. There are 4 boys and 4 girls. 4 boys and 4 girls. Listen carefully. 4 boys and 4 girls, and the condition remains the same. That is, exactly 2 girls sit together. Exactly 2 girls sit together. So what will happen here? What will happen here? Now you guys tell me what will happen. Now what is that I need to do? 2 girls are sitting together. First step, whenever you see exactly 2 girls sitting together, what is that you need to do? You need to place your boys. Boy, 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 boy. Next step, you need to create spaces between them. Spaces are created. These 4 boys, okay, these are the ones, okay. But if you see, there were only 3 cases here. But how many cases will I have here? How many cases will I have here? Look, how many girls are there? Girl, 1, 2, 3, 4. 4 girls are there. So how many cases will come? They can be 1 and 2. 1 and 2 can sit together. Or next, what can happen? 1 and 3 can sit together. Or 1 and 4 can sit together. Next, 2 and 1 is already done. 2 and 3 can sit together. 2 and 4 can sit together. Next, 3 and 2 is already done. 3 and 4 can sit together. So how many cases will I have here? 1, 2, 3, 4, 5, 6. 6 cases I will have here. 6 cases. Here only I had 3 cases, but I have here 6 cases. 6 cases. Now tell me your approach. What will it be? Listen carefully. Listen carefully. This is what? Nothing but what? 1 and 2 means girl 1 and girl 2 are sitting together. Girl 1 and girl 2 are sitting together. This means what? Girl 1 and girl 3 are sitting together. This means what? Girl 1 and girl 4 are sitting together. Now take up any one among them. Let me take girl 1 and girl 3. When girl 1 and girl 3 are sitting together, what will happen? Exactly 2 girls are sitting together, meaning other 2 girls, that is girl 2 and girl 4 must be sitting, not sitting to, they should not be sitting together. They should not be sitting together. They should not be sitting together because exactly 2 girls are sitting. These 2 cannot sit next to each other. Now start applying. Now, the girl 1 and girl 2, girl 1 and girl 3, this girl 1 and girl 3 can occupy how many positions? 1, 2, 3, 4, 5. It can occupy 5 positions. Next, they can rearrange among themselves in how many different ways? 2 factorial ways. Now, these 4 boys can rearrange among themselves in how many different ways? 4 factorial ways. Now, what all are we done with? We are done with arranging boys here. Boy 1, boy 2, boy 3, boy 4 and positions are done. Now, start thinking. Now, girl 1 and girl 3, one set was done. Who were remaining? Girl 2 and girl 4. The girl 2, when she walks in, in how many different ways can she sit if girl 1 and girl 3 has occupied, let's say, one of these positions. Girl 1 and girl 3 has occupied one of these positions. How many different ways can girl 2 sit? She can occupy this position, this position, this position, or this position. In how many different ways can she sit? 4 different ways. Now, let's say girl 2 occupied this position. This position. Now, girl 4, when she walks in how many different ways can she sit? 1, 2, and 3. 3 different ways. Yes? Yes? Now, is it done? Is it done? Is there anything more to be done? What is that? We need to add these 6 cases into count. We solved for one situation, but we needed answer for all the situations. So, I need to multiply a 6 here. I need to multiply a 6 here. And this will give our answer. Yes? So, guys, please calculate this. Drop your answers in the comment section. That will be your homework, a small homework. Yes? Now, let's go with the next type of questions. And what are they? What are they? Circular arrangement. Circular arrangement. Circular arrangement is one tricky part, guys. Circular arrangement. If you understand circular arrangement once, then it is done. But till you understand, it is impossible to solve. Okay. Now, let's take a circle first. Circle first. This is about circular arrangement. Okay. Circular arrangement. I'm taking a circle first, and there are 4 people and 4 chairs. In how many different ways can 4 people sit in 4 chairs in a circular arrangement will be the question to you. What will you do? Before previous question you guys have doubt. Who is asking that? Srishant is asking that we can arrange girls as 2-1 also, but 2-1 and 1-2 are the same. So I've taken one case here. But what do I do to consider the 2-1 case also? I multiply here with 2 factorial, Srishant. If you can see, what did I do? To take both the cases, that is G2 G1 and G1 G2, what did I do? I multiplied here with 2 factorial. For all the 6 cases, it will be counting. Yes? Okay, Srishant? Okay, cool. Now, let's move ahead. Any other doubts with respect to this question? This is a very important question. Once you develop such thinking without using formula, what are you doing? You're cracking every single question that is thrown at you, but you need to understand the logic behind it. What is selection? What is arrangement? Yes, if you are once perfect in that, any question that is posed to you will be a makhan, cakewalk. Yes, let's go to the next question that we have here. What does it say? Circular arrangement. Everyone pay attention. Circular arrangement. What are we going to do here? There are 4 people and 4 chairs. The question will be something like this. There are 4 people, 4 chairs. In how many different ways can 4 people be arranged in 4 chairs in a circular arrangement? Now, many of you would have already, if I ask you to answer, you will answer there. What will your answer be? Let me guess what your answer will be. Your answer will be 4 factorial, and which is exactly wrong. Why is it wrong? Why is it wrong? Look at it. Now, I have a circle here. Now, if I break open this circle, what will I have here? I will have a linear arrangement. What will I have? I will have a linear arrangement. And let me make 4 places. 4 people are there, right? Let me place 4 chairs. Now, if I place a person over here, let's assume this is you sitting here. Now, if I ask you where are you sitting, what will you tell? You can tell that you are sitting second to the left or third to the right. But now, if I place the same 4 chairs over here, and if I make you sit here, will you be ever able to tell me where you are sitting? No. Why? Because this is a circular arrangement. In circular arrangement, you do not have reference point. Now, look here. Here, there is a reference point, so I can tell your position. But here, there is no reference point. Since there is no reference point, I cannot tell the position of this person. Now, when there are 4 people, 4 chairs, what is that you need to do? Whenever the first person walks into the room which consists of a circular table, now this is the circular table and this is our room. Whenever the first person walks into the room which consists of circular table, whichever seat he takes will be the only way he can sit. So I am writing 1 here. Now, into whenever the person sits there, he creates a reference point. What will he do? He'll create a reference point. When the second person walks in, among the 4 people, when the second person walks in, that second person can sit first to the right. Yes, first to the right, second to the right, third to the right, or first to the left, second to the left, or third to the left. What is happening now? Once the person is seated, reference point is created. When the second person walks in how many different ways can he sit? He can sit in 3 different ways. Third person walks in how many different ways? 2 different ways. Now, fourth person walks in how many different ways? 1 different way. Now, if I ask you another question here, if I add another question here, if there are 5 people and 5 chairs, quickly answer, guys. 5 people, 5 chairs. Now, first person when he walks in, he can sit in only 1 different way. The next one when he walks in, there were 5 chairs. Yes, there were 5 chairs. I'll add another chair here if you want. First person, he sat here. So, when the second person walks in, among the 5, how many different ways can he sit? 1, 2, 3, 4. He can sit in 4 different ways. Next, 3. Next, 2. Next, 1. Yes. Now you would also say this, sir, this looks like a factorial, so I'll write it as 3 factorial. Sir, this also looks like a factorial, so I'll write a 4 factorial. This is wrong. Why is it wrong? Let's say I have this time. 3 people, 5 chairs. 3 people, 5 chairs. Same circular. 1, 2, 3, 4, 5. Okay, when the first person walks in how many different ways can he sit? Let's say he sat here, here's the only way he can sit. Now, when the second person walks in how many different ways can he sit? First, second, third, fourth. He can sit in 4 different ways. Now, when the third person walks in, he can sit in only, let's say, the second person who walked in, who sat here. So, he can sit in 3 different ways. Now, so we cannot say that it is factorial directly. It appears to be a factorial, but it is not a factorial. Whenever the number of people are less than number of chairs, it cannot be a factorial. So one note that we got to make here, that is linear arrangement. If there are r people, r chair, it is r factorial. But if it is circular arrangement, r people, r chair, it is r minus 1 factorial. R minus 1 factorial. Yes, everyone able to understand? Anybody, any doubt till here? Anybody, any doubt with respect to questions on circular arrangement? Ask me now, we'll beat it out. Yes? Anybody? If you guys are able to follow, you know what to do. You have to drop a I in the chat box. Great. Everyone is able to follow? Well, if you have any doubts, please let me know. I'll follow it up. Meanwhile, you'll get some time to take it down quickly. And you also know what to do when you're done taking it down. Sagar, you are the first lad in the entire batch who typed I perfectly. That is, he typed AYE. Guys, did you happen to try any questions on permutations and combinations yesterday or today, for that matter, after looking at the video or after the live session of ours? How are you guys feeling? Is it becoming better than before? Is it easier to solve the questions? Is your approach changing? Yes? Are you able to find some changes within yourself? And how are you guys preparing? Yes? There was one question also asked in the Telegram group. Nasreen, Sagar, Dharni, Srishant, there was one question that was asked to you. If a programming class is provided to you free of cost to boost your preparations for the examination that is coming up, WILP and NLTH, would you attend? Would you like to take sessions on programming? Yes or no? You have to answer that in the Telegram group that we have, so that we can take a count of number of people interested. Also ask your friends that such and such programming classes will be given for free. If they are interested, ask them to join the Telegram group so that we can help them with the programming part to clear this examination that is coming up in time. And this is once in a blue moon opportunity, guys. There has been we all know that we are all going through a tough time. This has never happened before. This type of a situation, like pandemic like situation, had never come before, and it is right at our doorstep. And an opportunity like this, where Wipro is giving close to 10,000 opportunities, is phenomenal. So please do not miss this out, and do whatever preparation you can do at the best of your abilities. Do not give excuses for these few days, and trust me, you will succeed. Just don't give excuses to yourself. Okay? Are you done taking it down? If you're done taking it down, you know what to do. Be fast, be quick. You don't have much time. We have very small time and we have to do a lot within that. Okay, so let's get started. Let's get started. Give me the video, please. I'll take those questions up in miscellaneous questions, Rishant. Okay, or you can ping me personally. Okay, let's have a look at the next type of questions, that is forming words. Forming words. These are frequently asked, people. Forming words. These are frequently asked. Whenever such type of a question appears, what is your approach supposed to be? Let me take up a few words. Let's take hate, India, calculator, engineering, your favorite letter at the end. Okay. The question will be something like this. Using letters HATE, how many words can be formed? How many words can be formed? The first prerequisite that you need to understand that every word need not have to give a meaning. Every word need not have to give a meaning. Like HEAT is also a word. How many words can be formed? He is just asking. So how many words can be formed using the letters HATE? HATE. Now pay attention. Have we solved such type of a question where we had 4 people? Where we had 4 people. So in how many different ways can I rearrange 4 people in? Answer in the comment section quickly. 4 people can be rearranged in how many different ways? They can be arranged in 4 factorial ways. It is similar to the question where only 4 people were there and they had to be rearranged. In how many different ways can they be arranged? 4 factorial ways. Now, coming to the next question. I have India here. How many letters do I have? 1, 2, 3, 4, 5. So, 5 letters can be rearranged in how many different ways? 5 factorial ways. But it does not end. What happens here? I have to divide it with something. What is that? I have 2 eyes here. If you observe, I have 1 eye here and 1 eye here. So there is a repetition of 2. So I have to divide it with 2 factorial. Do not panic. I'll tell you why we have to divide. I'll describe it to you in few minutes. Now let's follow. Let's try to calculate all of them. Now how many letters do I have here? 3, 6 and 9 and 10. So what do I need to do? 10 factorial divided by how many C's do I have here? 1, 2, 1 and 2. That's it. Calculator. Okay, 2 factorial. Now, how many A do I have here? A I have 2. Again, I have to divide it with a 2 factorial. Next, L how many do I have here? 2. So, I again have to divide it with a 2 factorial. C is done. U, no. L, no. A, no. A is done. T is done. O is done. So, this is my answer. So, how do I arrive at the answer? First, I check the number of letters. How many letters do I have? 10 letters, 10 factorial. And I divide it with the repetition. How many? 2 C is repeating how many times? 2 times. A is repeating how many times? 2 times. L is repeating how many times? 2 times. So it is done. Now, coming to the word engineering, your favorite word. How many letters do we have here? 3 and 3, 6, 6 and 3, 9, 9 and 2, 11. So, 11 letters can be arranged in how many different ways? 11 factorial ways. They can be arranged in 11 factorial ways. Divided by, what is repeating here? E is repeating how many times? So, what do I need to divide it with? I need to divide it with the 3 factorial first. Next, N is repeating how many times? 3 times. So, I need to divide it with 3 factorial again. 3 factorial again. G is repeating how many times? 2 times. So, I have to divide it with 2 factorial. I is repeating 2 times. So, I have to divide it with 2 factorial. So, N is done, E is done, R is done. So, this is my answer. This is my answer. So this is how you solve it and approach a question which is given on forming words. But to understand the logic behind it, let's try to understand. We cannot digest something without a logic. So let's try to understand the logic. What is it? India. Let me take this word that we have here, INDIA, India. And I can rearrange it something like this. Can I write it something like this? N, D, A, I, and I. I and I. Now I say this is I1 and this is I2. This is I1 and this is I2. Again, what is the different way I can write it as to be NDA I2 I1. Now, what did I do? I used to consider all the letters and find out how many different ways they can be rearranged. It was 5 factorial. But I used to divide it with a 2 factorial. Why did I do it? To eliminate this repetition. To eliminate this repetition. I1, I2 and I2, I1 are same. If I write it as NDA, I1, I2, this I is what I have written. But when you see, it is one and the same. It is I and I and I and I. Yes. So I have to divide it with 2 factorial. I have to divide it with 2 factorial. If you want, I can take a bigger example. Now, if I say a letter was something like this, NDA, I1, I2, I3. I1, I2, I3. So answer will be what? 1, 2, 3, 4, 5, 6. 6 factorial divided by, I is repeating 3 times, so I have to divide it with 3 factorial. Why do I have to divide it with 3 factorial? Look here. NDA will come the same way. Next thing what can happen is I1, I3, I2. Next thing that can happen is I1 will come, I1 is done. I1, I2, I3 is done. So I will have here I3, I1, I2. Next, I3, I2, I1. Next, I2, I1, I3. Next, I2, I3, I1. Yes, all these 6 cases needed to be eliminated. So I divide it with how much? 3 factorial. You understood why we are dividing it with 3 factorial? Yes, everyone. Anybody, any doubt why are we doing it? Yes. Now, let's move to the next question then. If you are done understanding, if you are done with this question, let's move to the next question. Everyone, now, let's move. Let's move quickly. Now, the next question is something like this. Pay attention, pay attention. All vowels are together. All vowels are together. Okay, the condition is all vowels are together. How many words can be formed using a word algorithm. If all vowels are together. What are the vowels that I have here? First vowel I have is A, the next one is O, the next one is I. Other than these, do I have any vowels? No. What are the consonants that I have here? L, G, R, T, H, M. What are the consonants that I have here? L, G, R, T, H, M. Now, what does the condition say? In permutation and combination, we always start with whatever the condition is given to us. What does the condition say? It says all vowels are together. All vowels are together. Guys, have you solved a similar question previously in yesterday's class? My question is, have you guys solved a similar question in the previous class? Yes. What is that, Srishant? What is that question? Yes. What is that question? All boys sitting together. Isn't it similar to the question where we solved it as to be all boys sitting together and we considered them as to be a single unit. So how many consonants do I have here? 6 consonants I have. Plus 1 unit, A, O and I will be moving as a single unit. So how many do I together have? I have 6 plus 1, 7. 7 people can be arranged in how many different ways? 7 factorial ways. But is it the end of it? No. Why? Because A, O and I can rearrange among themselves. So how many different ways can 3 people rearrange among themselves? They can arrange in 3 factorial ways. 3 factorial ways. Yes? Able to follow? Revati, perfect answer, Revati. Srishant, your answer is perfect. Perfect to the last point. Yes? Now, let's come to something like this. Let's say all vowels are together, algorithm is done. Let me take your favorite word again, which says engineering. Okay? Engineering. So tell me now, if all the vowels are together, in how many different ways can the word engineering be written? So what are my vowels here? E, E, E. I, how many do I have? I and I. Anything other than this? Now, what are my consonants here? I have N, N, N. How many G's? G and a G. Other thing that I have, anything that I've left out? No. So totally I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. One thing that I've missed out. What is that one thing? R I have missed out. Okay? R I have missed out. Yes? Now, look at it. Now, what do I have to do? I have to treat all the vowels as to be a single unit. Now, how many consonants do I have here? 1, 2, 3, 4, 5, 6. 6 and 1 unit, 7. 7 factorial. 7 factorial. Is it 7 factorial into, what does that have to? They can rearrange among themselves. In how many different ways can they rearrange among themselves? 5 factorial ways. But is this the end of it? No. Why? Because I can see that n is repeating 3 times. So what is that I need to divide it with? I have to divide it with 3 factorial here again. Now g is repeating 2 times. So I have to divide it with 2 factorial again. 5 factorial I have here. Now I have 3 e is repeating here. So I have to divide it with 3 factorial into I is repeating 2 times 2 factorial. 2 factorial. Yes? Yes, everyone? Able to follow? Yes or no? Yes or no? Are you guys able to follow? Yes or no? Now, if I have a word something like this, logarithm. Logarithm, what will you do? Am I missing with the spelling? Is it L-O-G-A or L-O-G? Is it perfect, the spelling? Arey, correct me with the spelling if there is any mistake here. What do you think, guys? It is correct? Now, if it is correct, then let's start dealing with it. L-O-G-A or L-O-G? L-O-G-A I have. Logarithms. Okay, what will I have to do? I have to separate the vowels. What are they? A, O and I. What are my consonants? L, G, R, T, H, M. Logarithm. Yes? What do I have to do? Single unit. How many are there? 3 and 3, 6. 6 and 1, 7. So what do I have to do? 7 factorial into they can rearrange among themselves in 3 factorial ways. Yes? Anything in repetition? No. So this is my answer. So now, quickly after this, we will be discussing one peculiar question where we will be discussing vowels in odd position. Vowels in odd position. So quickly take the screen down. I'll give you less than a minute to do it. And as soon as you are done, you know what to do. Drop a MA in the chat box, guys. Quickly. Are you guys done? Are you guys done? Be quick and drop a MA in the chat box. Venkatesh, are you done taking it down? Okay, guys, let's get started with the next question of ours. Let's have the video, please. Roll the comments up. Now, the question will be something like this. All vowels are in are in odd position. All vowels are in odd position. Okay, the word is algorithm. The word is algorithm. Okay, how many letters do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. To form a nine letter word, how many blank spaces do I need? I need 9 blank spaces. 3, 3, 6, 7, 8, 9. Okay, what does he say? He says all vowels are in odd position. In permutation and combination, where do I start with? I start with the condition that is given to me. What is the condition? Vowels in odd position. What are my vowels here? If you observe, my vowels are A, I'll write it here for you, A, O and I. These are the 3 vowels. What are my consonants here? Consonants are L, G, R, T, H and M. Yes. Now, what are my odd positions here? To form a 9-letter word, I need 9 blank spaces. To form a 9-letter word, I need 9 blank spaces. What are my odd positions here? 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9 are my odd positions. Do you agree? Do you agree? Now, what are the positions that these vowels can occupy? When the first vowel walks in. So what is the condition here? 3 people. How many chairs? 1, 2, 3, 4, 5. 5 chairs. Now, what will happen? Whatever is greater will be assigned to the later. When the first vowel walks in how many different ways can he sit? He can sit in either first, second, third, fourth or fifth. So he can sit in 5 different ways. Let me say A sat here. A is sitting here. A is sitting here. Now, when the second vowel walks in how many different ways can he sit? He can sit in 4 different ways. 4 different ways. Let me say O is sitting here. O is sitting here. Now, when the third vowel walks in, how many different positions can he occupy? 1, 2, 3. So he can sit in 3 different ways. So let me say I is sitting here. I is sitting here. Now, what is done? All vowels in odd position is done. How many blank spaces am I left out with? 1, 2, 3, 4, 5, 6. 6 blank spaces. How many letters am I left out with? 1, 2, 3, 4, 5, 6. 6 letters, 6 positions. In how many different ways can they be arranged? 6 letters, 6 positions. In how many different ways can they be arranged? They can be arranged in 6 factorial ways. 6 people, 6 chairs can be arranged in how many different ways? They can be arranged in 6 factorial ways. So this gives me the answer. This gives me the answer. Now, how many of you understood it inside out? Anyone who wants me to repeat it for you? Anyone who wants me to repeat it for you? That's okay. I am here for the one person who could not understand. I am here for the one person who could not understand. Anyone who wants me to repeat it? Okay. Well, I presume the class is comfortable and we'll move to the next type of questions. Next type of questions. What are they? Handshakes. Handshakes. Everyone, handshakes. Before that, I'll tell you a small concept here. Let's say there are 5 people. I'll number them as to be 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Now, whenever there is a question on handshakes, it will always talk about how many handshakes are made. If there are 5 people, how many handshakes can be made? Just observe. 1 can shake with 2, 3, 4, 5. Yes. So what is happening? It can make, if the total number is n, if the total number of people are n, he'll make how many handshakes? One person will make how many handshakes? N minus 1. Why? Excluding himself, he'll make handshakes with one person. So I'll have to write n minus 1. Yes. Now, I have to divide it with a 2. Why? Because if you observe, 2 will also make similar handshakes. Like 2 will make with 1, 2 will make with 3, 2 will make with 4, 2 will make with 5. Yes. But if you observe, 1 and 2 have already made a handshake and this is being double counted. So to remove this double count, I have to divide it with a 2. I have to divide it with a 2. Now, this is for one person. I am talking about one person. But for all the n people, I have to multiply it with n. I have to multiply it with n. n into n minus 1 divided by 2. This is my formula, the only formula that we have for handshakes. If you know this, you can solve any question that is posed to you at different levels as well. I'll take this formula to different levels. Just stay connected and focus towards the screen. So let's have the first question. What does the first question say? How many, what is the question? Please read it out for me.
How many handshakes will be there in a room of 20 members?
Okay, okay. How many handshakes are there? How many handshakes can happen in a room? In a room consisting of 20 people. 20 people. If each person shakes his hand, with every other person, okay, the question will be something like this. In a room consisting of 20 people, how many handshakes will happen if each person shakes hand with every other person? Now, how many people do I have? I have 20 people. 20 into 20 minus 1. What do I have to do? I have to simply apply the formula. 20 minus 1 divided by 2. That will give me how much? 2 ones, 2 tens. Yes, that I will have a 19 here. 19 into 10 is 190. How many handshakes? 190 shakes. 190 shakes. The other way they can ask you a question on handshakes. Okay. A room consisting of, now they will tell you the number of people inside the room, and they'll ask you, here what happened? The number of people in the room were mentioned. And they were asking you about the handshakes. But what happens if they give you the number of people? If there are 153 people, if there are 153 people in the room, if there are 153 handshakes, so this was what? Handshakes. If there are 153 handshakes in the room, where each person shakes hand with every other person, I'm not writing that, each person shakes hand with every other person, how many handshakes will be there? How many people will be there? The question will be, how many people will be there? If there are 153 handshakes in a room, if there are 153 handshakes in a room, where every person shakes hand with other person, how many people are there in that room? The question will be something like this. So again, what do I have to do? Now I know the number of handshakes. My only formula I know is n into n minus 1 divided by 2. That is equals to number of handshakes. Number of handshakes is given to me as 153. Now, observe here. Now, what do I have to do? I have to simply solve this. So, this will give me how much? N square minus n into 150 into 3 gives me 306. If I take this 306 onto this side, it gives me 306 is equals to 0. This is the equation that I learned, quadratic equation. Now, I have to solve this. Now, 306 I have here. I know 18 square. You have to memorize squares till 25, guys. I know that 18 square is 324, whereas 17 square is 289. Yes. Now, so it must be somewhere the minus the difference between them must be 1, and the multiplication must be 306. So the only way I can have it is, I presume it is 18 into 17. If you multiply 18 into 17, you will get the same answer. Now let's check. What will I do? I have to multiply here. 56, I'll have 6 here, 5 here. 7 into 1, 7, 8 into 1, 8. 15 and 5, I'll get a 20, 0, 2, 2, 2, 1 into 1, 1, and a 3, 306. If you could not understand how I multiply it, you will have to watch our videos on speed math. Now, observe, it is giving us 306. Now, 9 square, n square, I have to get a minus here. So, what is that I need to write here? 18n. I have to get difference has to be 1. So, what is that I need to write here? Plus 17n minus 306 is equals to 0. Now, what will I do? I'll take an n common out here, n minus 18 plus, I'll take 17 common here, which gives me n minus 17 into 18 gives me 306, that is equals to 0. So, the thing that I've got here is n minus 18 into n plus 17. So, the value is n is equals to 18 or n is equals to minus 17. The positive value I have to take, I have to eliminate the negative value. The number of people in that room is 18. The number of people in that room is 18. Yes, everyone able to follow? Now, if I change the same question I'll change. If there are 66 handshakes, let's say there are 66 shakes, I'll write shakes. If there are 66 handshakes in that room where every person shakes hand with every other person, how many people are there in that room? Anyone who can answer me? What will happen? n into n minus 1. N into n minus 1 divided by 2 is equals to 66. What do I need to do? N square minus n. N square minus n, 2 goes there. So that gives me how much? 136. Yes? 132. Yes. If I take it onto this side, minus 132. That is equals to 0. That is equals to 0. So this will be what? How do I have to see? If I know the squares, I can deal with it. 11 square is 121. 12 square is 144. So it is somewhere between 11 and 12. So what do I have to do? I have to write it as n square minus, I have to get minus 12n plus 11n minus 132 is equals to 0. I can directly write, I'll take n common. The one will be n minus 12. N minus 12. The other one will be n plus 11 is equals to 0. So n value positive I'll get is 12. So how many people are there in that row? There are 12 people. Who all gave the answer right? 12 and 6. Revati gave the answer right. Perfect, Revati. Good one. Monica, yes. Monica, 12 handshakes. Beautiful, Monica. Nandini, 12 handshakes. Beautiful. Nasreen, good answer. Here on this side where Venkatesh is there, that is the YouTube side. Siva says it's 12. Beautiful, Siva. It is the right answer. Venkatesh, why are you not answering, dear? I always look for answers from you. Okay. So these are the questions on handshakes. Now if I take these questions on handshakes to other types where we'll have the same type of formula, what will that be? Let's have a look. But before that, copy this, whatever is there on the screen, and we'll get back. Yes, Venkatesh, we can also always go with that approach where you can substitute the options there and try it out. Yes, you can go with it. It is also a good approach. Okay, give me the video, please. Okay, look, the next question, what does it say? The next question is about a points. Okay, the question will be something like this. A plane consists of a 2D plane. Okay, a plane consists of 9 points. 9 points. A plane consists of 9 points. Okay, no three points are collinear. No 3 points are collinear. How many lines can be formed? How many lines can be formed? Okay, no 3 points are collinear. How many lines can be formed? Yes, tell me. Now start imagining, start thinking. Now what does it say? No 3 points are collinear. No 3 points are collinear. Meaning what? No 3 points are collinear meaning 2 can be collinear. 2 can be collinear. To form a line, how many points do I need, guys? Ek line. What, to form one line, how many points do I need? I need 1.2 point. Yes. To form a line, I need 2 points. I need 2 points to form a line. So totally how many points do I have? I have 9 points. So how many different ways can 2 points be selected out of total of 9 points? How many different ways can 2 points be selected out of total of 9 points? Very good. Srishant, what is it? It can be 9C2. It is 9C2. In how many different ways can it be selected? 9C2 ways. So this gives me the answer for this. We are going with miscellaneous type of questions here. Now, I have taken you out of the mode here. Now I'll get back to you. Now, listen. There is a meeting consisting of 17 people. Okay? Consisting of 17 people sitting around a circular table. Sitting around a circular table. Okay. Each person does not make handshakes with their immediate neighbors. Immediate neighbors. How many handshakes will be there in this meeting? How many handshakes will be there in this meeting? My question is simple. There is a meeting consisting of 17 people sitting around a circular table. There are 17 people sitting around a circular table. Imagine, start imagining 17 people sitting around a circular table. Okay. Now, each person does not make handshake with their immediate neighbor. Immediate neighbor meaning what? In a circle on to my left and my right. Immediate neighbors, they do not make handshakes. So, how many handshakes will be there in that meeting is the question. Now, observe here. There is one circle. There is one person sitting here. Now, there will be how many people in this circle? 17 people in this circle. Now, but he does not make handshakes with his immediate neighbor. Okay, he does not make handshakes with his immediate neighbor. Now, what were we doing? We were removing out of the total of n, we were removing one person. When were we removing one person? Start thinking. When were we removing one person? When he could not make handshake with himself, I was removing one. But with how many cannot he make handshakes here? With 3 people. So how many do I have to subtract here? -3. I have to subtract it from -3. Now, the handshake with the first person and the second person, that is first person and some n person, will be repeated twice. So I have to divide it to 2. Now, one thing that I have to multiply here is what? The number of people n. So that will give me the answer. The number of people is how much? 17. 17 minus 3 is how much? 17 minus 3 is 14. 14 divided by 2 I have here. 2 sevens. Yes, 2 sevens. Okay, 17 sevens is how much? 17 10 sevens is how much? Guys, you have been writing tables from past how many days? We have been asking you to write tables from past the first day that we started. So what is 17 sevens? Sir, can you repeat Can you explain again, Srishant? Yes, I can do it. Let's, yes. Sure. Just listen to it. Simple thing. What is happening here? Now, listen here. How many people are there in this circle? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll add one more here. 17 people are there in this circle. Now, each person cannot make handshake with his neighbor. This person cannot make handshake with this person. Say, this person cannot make handshake with his neighbor, this person. Yes? So, how many handshakes will be made if if 17 people sitting around a circular table cannot make handshakes with their immediate neighbors? So, when we were dealing with what type of arrangement there, n-1 we took, where every person was making an handshake with every other person. So only one, we were deducting only one. Why were we deducting one? Because he cannot make a handshake with himself and that doesn't count. So here, how many people he cannot make handshakes with? First one is he himself and his immediate neighbors, 2. So I have to remove how much? n-3 have to remove, total number of people, -3 have to remove. Yes? Now, I have to divide it with 2 because he making a handshake with this person, let's say this person, is same as this person making a handshake with this person again. Yes. So there will be a repetition. How do I remove it? I remove it by dividing with a 2. Now, what will this n represent? I have calculated this n-3 divided by 2 for one person. But how many people are there? 17 people. So I have to write a number of people here, n. Yes. So this gives me how much? 17 sevens is 119. Yes, simple calculations which gave me to arrive at the answer which says 119. Yes, everyone is it able, are you guys able to follow? Yes. The same question if I take it ahead. Now, he'll ask you something like this. A pentagon has how many diagonals? A pentagon has how many diagonals? What is a pentagon? A pentagon has how many sides? 5 sides. 1, 2, 3, 4, and 5 sides. A pentagon has how many diagonals? Do you have to write it and solve it? If he gives a hexagon, will you have time to write it and solve it? But you might end up missing 1 or 2. Yes. But if he gives an octagon, again you might miss. So as the numbers increase, what will happen? You will start missing them. So what is the approach that you should have? Now start thinking. To form a diagonal, what is that you need? You can only form a diagonal with the point which is not the adjacent neighbor. You cannot form a diagonal with the points which are adjacent to this point. The points which are adjacent to this points cannot help me form a diagonal. So the formula here, what will it be? n-3. What am I telling you? Or I am teaching you. I am not giving you a fish directly. I am teaching you to catch a fish. To catch a fish, I am telling you. What am I telling you? I am asking you how many points can I have to eliminate. This is one point that I have to eliminate, as same as this case. This is another point that I have to eliminate, which it cannot form a diagonal. This is another point within this pentagon which I have to eliminate, with which it cannot form a diagonal. Now, again, I have to divide it with 2. Why? Because diagonal, if I name it as AB diagonal is same and BA diagonal is also same. So what is being done here? Double counting. So what is that I need to do? I have to divide it with 2. Next, this is for one diagonal, but for 5 diagonals, what do I have to do? I have to take all the points into consideration. So I have to multiply it with the n. So how many diagonals does a pentagon have? Just substitute 5 here. If I substitute 5 here, what will I get? 5 into 5 minus 3 is 2. 2 divided by 2. 2 cancel. I have 5 diagonals. Now, the question for you is octagon. How many diagonals does an octagon have? Octagon meaning 8. So how many will be there? 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. How many diagonals does an octagon have? If you want to check it here, yes, you can check it. Obviously, you can check it. This is another first diagonal, second diagonal, next third diagonal, next fourth diagonal, next fifth diagonal. Yes, these are the 5 diagonals that are possible. These are the 5 diagonals that are possible. But can you do the same here? Can you start drawing and arrive at the answer? No. So how do we are supposed to do? One point is here. It cannot, to form a diagonal, it cannot use the adjacent points. That is this point and this point. So what is that I need to do? N minus 3 I need to do. I have to divide it with 2 because why? Because I'll have a repetition where the diagonals will be double counted. And I have to multiply it with an n because the number of diagonals I have to consider. Yes. So this will give me how much? N is 8 points I have. 8 into 8 minus 3 is how much? 5. 5 divided by 2. This is 2 1 times, this is 4 times. 5 and 4 is 20. I have 20 diagonals straight. 20 diagonals straight. Yes. Dharani, beautiful answer. Monica, yes. Are you guys able to follow? Are you guys, each and every one of you, are you guys able to follow? Yes, we'll be bringing this session to an end exactly at 9:30 p.m. Yes. So, is this okay for you? Are you guys able to understand? Can we move further? Yes. Now, is there any other question that we took up in miscellaneous? Okay, that's it. Fine. Guys, quickly take it down and we'll be moving to coins. We'll be dealing with probability of coins. We'll be dealing with probability and coins. Important topic, probability and coins, and it is very interesting, trust me. It is very interesting and very easy to learn. There are few simple things that you need to understand when it comes to coins, and you will be able to solve any question that is posed to you. Okay. Ultra low latency select ಮಾಡಿಲ್ಲ ಅಲ್ಲಿ. Okay, let's have the video and let's get started with coins here. Okay, this will be under the topic of probability, which is nothing but what? Combinations part of the permutation and combination. And this is very important, guys. So pay attention and let's try to solve them together. If I toss one coin, my first question to you, if I toss one coin, how many possible outcomes are there? It can be a tail or a head. So how many possible outcomes? 2. If I toss 2 coins, how many possible outcomes? How many are there? 4. If I toss 3 coins, 8. If I toss 4 coins, 16. If I toss 5 coins, 32. 6 coins, 64, and so on. Yes. If you observe here carefully, what is happening? Number of cases in number of coins is how much? 2 power 1 here. Here it is 2 power 2. Here it is 2 power 3. Here it is 2 power 4, 2 power 5, 2 power 6. So, for n number of coins, what will be the number of cases? 2 power n. 2 power n. Now, if I write the case here for 2 coins, what will it be? Head, 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 tail, tail. And this will be head, tail, head, tail. These are the 4 cases. Now, if I ask you some question, what is in under 2 coins, if I ask you some question, which is very simple. If I ask you what is the probability of getting 1 head, you will be able to answer. What is the total number? What is probability? Probability is nothing but number of favorable cases upon total number of cases. Yes, total number of cases. Yes, do you agree with this? No. Favorable cases of getting 1 head. Where is that? 1 and 2. I'll write 2 here. Total number of cases is how much? 4. I'll write 4 here. But if I move a little bit ahead, and if I ask you when 3 coins, that what is the probability of getting 1 head? 1 head. You can still have the patience to write the table. What will that table look like? Head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail. Next, head, tail, head, tail, head, tail. This is the technique that we used to do in our school days. Yes. Now, this is how we write it. Now, probability of getting 1 head. What would you do? 1 head, where all they are there, I can look for it. 1 head, where is it? I can have 1 head here. The other one is here. The other one is here. So, what is probability? Number of favorable cases upon total number of cases. Total number of cases when there are 3 coins being tossed is how much? I can see it is 8. What is 1 head? 1 head is 3. 3 upon 8 gives me the answer. Yes. Now, if I ask you, what is the probability of getting 2 heads? 2 heads. You can still count. 2 heads is how much? 1 here. I have 1 here, 2 heads. Next 2 heads are where here. Next 2 heads are where here. So, it is again total number of cases 8 upon 3. 3 upon 8. Favorable cases is 3. Total number of cases is 8. What is my favorable case? That is getting a head. 2 heads. Getting 2 heads is my favorable case. Now, if you look at it, probability of getting 1 tail. What will be it? 3 by 8. 3 by 8 again. Now, how am I writing it? How to increase my speed? What is the trick here? What is the understanding that I need to have? Just observe. Now, there are 3 coins being tossed. Coin 1, coin 2, coin 3. Coin 1, coin 2 and coin 3. This, whenever I say 1 head, this 1 head can appear where all? It can appear in the first toss here, or it can appear in the second toss here, or it can appear in the third toss here. When I say 1 head, where all can it appear? It can appear in the first toss, second toss or third toss. All the coins are being tossed simultaneously, but it can appear in this position or this position, whereas the rest of them will be what? Tail and tail, tail and tail. Yes. So, where all can it appear? How many cases? 3 favorable cases. 3 favorable cases, I'll get a 3 by 8. Similarly, 1 tail, where all can it appear? If I change this diagram, 1 tail, where all can it appear? Similarly, it can appear in the first toss, second toss or the third toss. So, favorable cases is 3, total number of cases is 8. It is done. But if you can also look at this question where it says probability of getting 2 head. What does 2 head mean to me? Now, if I ask you something like this, probability of getting 2 tails, guys, probability of getting 2 tails. Now, 2 tails, if you observe, is also nothing but 1 head. 2 tails is also nothing but 1 head. 2 tails is also nothing but 1 head. So, 1 head can appear in what all positions? It can appear in these 3 positions. So, that will be my answer, 3 upon 8. 3 upon 8. So, irrespective of the number of coins that we are tossing, so we can solve this question in a snap. Why? The number of coins that are being tossed will be my favorable cases whenever it comes to 1 head and 1 tail. When and if there are 4 coins, if and he is asking a question about 3 heads, then it will be again the similar case, and we'll also be dealing with that. Do not stress your mind so much. Okay, you're fragile. Just listen to me carefully. Let's move ahead. This is one type of question that can be asked. Next, it can be asked what? Probability of getting at least 1 head, at least 1 head. What does that mean? At least 1 head meaning minimum 1 head. So, I can write the condition as 1 head or 2 head or 3 head. Yes, 1 head, 1 head or 2 head or 3 head. So what is my probability? Probability is nothing but total number of cases upon number of favorable cases. Number of favorable cases for getting one head. One head, how much is it? Favorable for cases for getting one head, how much is it? It can appear in 3 positions, 3. OR represents what operation? If you remember, OR represents what operation? Addition operation. 2 heads is nothing but what? 2 heads is nothing but one tail. One tail can appear in how many positions? 3 positions. Now OR represents addition operation again. 3 heads. Irrespective of the number of coins tossed, all heads, that is, this is 3 heads, right? Irrespective of the number of coins tossed, all heads and all tails will always be one. Always be 1. So now, total number of cases here, total number of cases is 8. So this will give me how much? 336,177 by 8. But I can also look at it something like this. The same question, that is probability of at least one head, I can also look at it something like this. When will we, I have a question for the class, that when will be probability equals to 1? When will the probability be equal to 1? The probability will be equal to 1 when the number of cases, the number of favorable cases is equal to the number of total cases. Yes or no? The probability will be equals to 1 only when the number of favorable cases is equals to, let's say, 8 divided by 8. That gives me 1. Yes? Yes or no? The total number of cases is equals to total number of cases is equals to number of favorable cases, only then the probability will be equals to 1. Now, total probability is 1. Now, if I subtract the one case where there are 0 heads, this is what? At least one head. If you observe here, the only case where there is no head is what case? Where all of them are tails. So if I remove that one case which is 0 tails, I'll get the same answer. I should get the same answer. So check with it. What is it? 1 head, 1. Probability 1. Total probability minus 0 head case. 0 head is how much? Irrespective of the number of cases, it will be how much? 1. Favorable case is 1. Total number of cases 8. So this gives me how much? Again 8 minus 1, 7, 7 by 8. The same as I got here. Everyone able to follow. Now these till 3 coins it is easy. But if I move further, what happens? There are few questions in my mind which bother me. What are they? 4 coins are there. Let's presume there are 4 coins. Now you guys have to answer. Probability of getting one head, if I ask you, you should be able to answer these ones. One head. This one head can appear in what all positions? It can appear in the first, second, third or the fourth. My probability is nothing but what? Total number of cases, that is 16. Favorable cases, how much is that favorable cases? 4. 4 upon 16. Now if I ask you, what is the probability of getting exactly 3 tail? What will be it? Favorable cases will be again 4. Again, total number of cases will be 16. And now, the problem arises when I ask you, what is the probability of getting 2 heads? So, whenever you do not understand the condition, what is that you need to do? You need to write it down. What does it look like? Head and head, tail and tail. Head and head and tail and tail. Now, have we solved somewhere similar type of question where we had to arrange letters? If you remember, guys, have we? Yes, we have. And what does that tell? 4 factorial divided by repetition of 2 and repetition of 2 here. What is that I need to divide it with 2 factorial into 2 factorial. Yes, able to follow everyone? Able to follow? Abhilash Verma is in the chat box. Okay, guys. Fine. That's it. You guys can see those, whatever everyone is putting the chart there? Yes, all of them can see, yeah? Okay. Well, guys. If there are probability of getting 2 heads, how do I calculate? This is what? 4 factorial divided by 2 factorial into 2 factorial. Still I have to divide it with what? Total number of cases. Total number of cases when it comes to 4 coins I have calculated it has to be 2 power n, that is 16. That gives me a 16 there. Yes. Now if I move a little bit further, now I give you 7 coins, guys. Now I give you 7 coins. Now, I ask you, what is the probability of getting 3 heads or 3 tails or whatever, 3 heads? What will you do? Whenever you do not understand the case, what are you supposed to do? Write it down, head, head, head. Next, tail, 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 tail. Next, how many coins do I have? I have totally 7 coins, 7 letters. So they can be arranged in how many different ways? 7 factorial ways. Next, what is that I need to do? 7 factorial divided by, yes, 3 factorial into 4 factorial divided, total divided by how many? Total number of cases when 7 coins are there, 2 power 7. Yes. Beautiful, Srishant. Srishant has already typed the answer before I could write it. I appreciate it. I appreciate it a lot. Yes. Everyone understood the at least case? My priority, I'll ask you. Everyone understood the at least case? Everyone understood how to calculate total number of cases? Everyone understood what my probability is? Probability is nothing but favorable cases upon total number of cases. Now, when the coins are number increase, will you get scared? No, right? Everyone? If a challenge is thrown to you to solve a question on coins, now will the class be able to solve it without any hesitation? I presume so, and I'll give you time to take it down quickly. After this, we'll move to the next question. Roger that, Abhilash. I roger that. Over and out. Remove him out of the meeting. Someone please remove him out of the meeting. And don't let him join. What say, guys? Should we remove Abhilash out of the meeting and continue our meeting, or shall we have him in the meeting? You can't, guys. I can. Don't challenge the host here. I am the host. Revati Gupta, you retracted some of your messages. My students won't agree. What say, students? Should we continue to bear him, or should we remove him? Okay, continue. Oh, a lot of pity for you. Well.
See, I win at that.
Okay, in the final part, we'll be discussing on questions on cards, or you want one more question on permutation and combination? I have one in my mind which you would like to take, I presume. Would you like another question there, or how many of you are comfortable with the cards, guys? How many of you are comfortable with cards? To solve any question on cards, let's have the video, please. So to solve any question on cards, what is necessary is, you need to understand the characteristics of cards. Once you understand characteristics of cards, any question is cakewalk. So let's try to understand what are the characteristics here. Okay. Now, a deck of cards consists of how many? A deck of cards consists of how many cards? A deck consists of 52 cards. Okay, 52 cards. Out of these 52 cards, how many are black and how many are red? How many black cards do we have and how many red cards do we have? We have black and red, and each one of them are 26 in number, and these are also 26 in number. Yes, within these black cards we have 2 suits, and in red cards we have 2 suits. They are called suits. What are they? What are the 4 suits that we have? One is spades, clubs, hearts and diamonds. Yes, spades, clubs, hearts and diamonds. Under the black or under the red, what are the 2 suits that come? One is hearts, the other one is diamonds. The remaining two, that is spades and clubs come here. And each one of them have how many cards? Each suit has how many cards? Yes, each one of them are 13 in number. 13 here and 13 here. Now, there are three types of cards now. One are number cards, the second one is face cards, and the other one is ace cards. What are number cards? Number cards are from 1 to 10. Very good. Yes? Do we have 1? No, we do not have 1. What are number cards? 2 to 9. 2 to 9. So 2 to 9, how many cards do I have? 2 to 9, how many cards do I have? 2 to 10, sorry, 2 to 10, how many cards do I have? So 2 to 10, every section I'll have 2 to 10. Every section 2 to 10. Every section 2 to 10 I'll have. 2 to 10 I'll have. Yes, 9 cards I'll have. 9 into 4 gives me how much? 36 cards in total. Now, how many face cards do I have? Each has KQJ. 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 So 3 into 4, I'll have 12 here. And ace cards I have 4. That is 1A here, 1A here, 1A here, and 1A here. So I'll have 4 here. So totally together, I'll have how much? 36 and 12, 48 and 4, 52 again. 52 again. With this knowledge about cards, we can solve any question that is posed to us. Basic questions that we come across is picking one card. Basic question that we come across is picking one card. Let's say I'm picking one card out of the deck. What is the probability of getting a black card? Probability of getting a black card. So, what is probability? It is nothing but favorable cases upon total number of cases. Total number of cases when I'm picking one card is how much? How many ways can you select one card out of total of 52 cards? You can do it in 52. See, one ways, which is nothing but 52 itself. 52 itself. Favorable cases will be how much? Black cards. In how many ways? 26. So, in how many different ways can you pick one card out of total of 26 black cards? It will be 26C1. So, this is nothing but 26 upon 52. 26 upon 52. Now, if I ask you, what is the probability of picking a face card? Quickly answer. Face cards, 52. Total number of cases is 52. Face card are how many? 12. You have to pick one. 12C1 is nothing but 12. Yes. Now, if I ask you, what is the probability of getting a number card? A number card, quickly, number card, probability of getting a number card. Total number of cases will remain, that is 52. 9, 36 I have. 36C1 is nothing but 36 again. Very good. Now, picking two cards. Let's move to picking two cards. What are we doing here? Picking two cards out of total of 52 cards. So, what will be my total number of cases? It will be 52C2. It will be what? 52C2. Yes. Now, if I ask you, what is the probability of getting, number cards? Number cards. Both are number cards here. Pick one, pick two cards. How many cards are we picking? Two cards. So, what will be total number of cases? 52C2. So, what is the probability of getting a number card? Number card is how much? 36. In how many different ways can you select two number cards out of total of 36 number cards? 36C2. It is done. Now, if I ask you, probability of getting no, I'll change it to exactly one ace. Exactly one ace. So, what will you do? Total number of cases will remain the same. That is 52C2. One ace. One ace meaning what? I have to have one ace card and any one. I can have any one other than ace. Pay attention, I can have any one card, but it must be other than ace because it is exactly one ace. Exactly one ace can be selected out of total of 4 cards in how many different ways? 4C1 ways, which is nothing but 4 again. Now, and represents what operation? And represents multiplication operation. Any one card among how many cards? Any one card among how many cards? Beautiful, Srishant. What does it say? Any one card among the remaining 48 cards. Why? Because I can have only one ace, so I have to remove all the 4 aces out of the total of 52 cards. 52 minus 4 gives me 48. 48 C1. Any one card other than ace. How do I select it? 48 C1. Now, if you guys will post a question, we will solve it together here. Anyone? I want one question from Nasreen, and one question from Nasima, and one question from Dharni, and one question on YouTube side from Priyanka and Venkatesh. So we'll solve these 4 to 5 questions and we'll end the session. Quickly, guys, everyone, pick. And anyone who posts the question first, we'll take that up first, okay? Quick. Question, guys. Okay, guys. You're taking a lot of time. So let me say one black, exactly one black and one red. One black and one red. Total number of cases, 52 C2. One black, in how many different ways can I select? 26 C1, which is nothing but 26 again. And one red, in how many different ways can I select? 26 C1, it is again 26. One black and one red. If I go dig deeper in this, what is the probability of getting one king, one red king, I'll say. One red king and one black queen. One black queen. One red king and one black queen. What will you do? Total number of cases will remain same, 52 C2. Favorable cases, what will happen? One red king. How many one red kings do I have? How many red kings do I have? Red are here. Red are here. And how many kings do I have? 2. In how many different ways can you select? One red king. 2. 2 C1, which is nothing but 2. Now one black queen, how many? Black, how many queens are there? 2. In how many different ways can you select? 2 C1. 2 into 2. Yes. One red king and one king spade. Okay. The same question I've close to the same question I've solved it. Yes. So let's change the question a little bit so that it will be different for others. One red king and one king spade. So one red king, it will be what? One red king will be 2 again. One king spade is what, dear? King, spade of king. Okay. Although it will be only one way. There is only one spade king, right? It will be 1. So Venkatesh, your answer will be something like this. Just check it out. 52 C2 total number of cases. Venkatesh's question is one red king, probability of one red king and what is that? One king of spades. One king of spades. One red king, how many? 2 C1, which is nothing but 2. One king of spades, there will be only one king of spades. I can select in only one way. Yes? Able to follow everyone? Able to follow everyone? Guys, one thing that I need to mention now is, guys, you have been doing a wonderful job. You have helped us a lot with respect to the subscribers and everything. But after this session, I would ask you to go like the previous session that we have already published. Yes, it takes less than a minute for you to go to our channel, look for our previous video, and just give it a thumbs up. It matters a big deal for us. So please do that for us. And we are thankful to each and every one of you who has recommended our channel to others, where we are teaching, we are doing this to you, we are giving these classes to you for free of cost. Yes, and it means a lot. Each and every one of your efforts are appreciated. Okay, so another thing that I want to mention you is that anyone, if you are not still in the Telegram channel, please jump into the Telegram channel where we'll be posting questions. And in time to come, if there is something called programming classes coming up, you'll also have updates there. So please join the session and also let us know about the question that is asked in the programming, in the Telegram about the programming sessions. Guys, is that okay? Yes, I'll answer that, Nasreen. I'll answer that in the morning, Nasreen. Well, guys, so with this, I'll bring this session to an end. You have been a wonderful, wonderful, wonderful class. Thank you so much. I appreciate your time and patience. Hope to see you soon. Till then, take care. Okay, with this I'll be bringing the session to an end. Thank you so much, guys. You can leave the meeting after you're done taking it down. Thank you, Monica. Thank you, Nasreen. Thank you, Dharni. Thank you, guys.